We are live. Hello, everybody, and welcome to Debate Prep for Kent Hovind, which is taking place tomorrow at 8:30 p.m. on Standing for Truth channel. So it's tomorrow, 8:30 on Standing for Truth. The link is in the description. I'm going to debate Kent Hovind, and the topic is going to be macroevolution. So here we are with TD Lane and the Dapper Dinosaur, and we're going to do some debate prep. I figure we're only going to let this run for about an hour. And yeah, so welcome, Lane. Welcome, Dapper. And I think what we can do here is, if you want, I can show you my intro, which I think we got it set for 10-minute intros. And then we can talk about where we expect things to go. I've got my, as I like to do, I have a bunch of supplemental slides that are right now very empty, but I have things that I'm going to fill them with based on topics that might come up. And yeah, I think that's what we'll do. How's that sound to everybody?
Awesome. Also, I'm probably going to save this to my Dapper on Other Channels playlist. So if you're looking at that playlist from my channel, make sure you hit the subscribe button.
Thank you for that plug. I appreciate it.
I'm plugging you on your own channel.
Yeah.
Which, by the way, before we start, if for some reason you are watching a stream on my channel and you are not already subscribed to TD Lane and Dapper, go and do that. Just go and do that real quick, because you should be subscribed to them too.
Agreed.
I'm sure everybody here is already I don't know how many people are here, but all 5 of you or whatever. I'm sure you're already in the know, but in case you weren't. All right, so let's do this thing. So the idea here is we are looking at macroevolution, which is a fun topic because it can go in so many different directions. And the way I'm going to take this is basically say, look, Kent says this stuff can happen, and that's silly because we can watch a bunch of things happen. So I'm not basing any of my arguments on like fossil record. I'm basing it all on things that we can directly observe, like actually in a lab, for example. So with that being said, let's do this. We're going to go to, there we go. And we are going to do that. Now, I am not going to, I'm not going to full screen this because where I am right now, I only have one monitor at my disposal. So I'm just going to kind of click through this, but I'm not going to full screen it. But the way that this works is that for each thing that pops, well, you know what, heck with it. I'll just full screen it. We can go through it. So whatever. Here's what we're going to do.
James, do you want me to time you or?
You know what? I'm going to set a timer right here for myself because I always have a timer going for myself when I do this kind of thing. But if you want to back me up, then I certainly won't argue.
Oh, sure, I'll back you up. I'll start on your first word. Just give me a second to get it started. Let's see. Timer set it to 10 minutes. You said?
Yeah, let's do 10 minutes, and we'll see. I've literally have not done this yet, so I don't know how long this is going to go.
I'll have you on stop.
We're going to see. All right, so here we go. 3, 2, 1, engage. All right. Hello, everybody. Thank you all for watching. Thank you, Kent, for being here. The topic tonight is macroevolution. So we obviously have to start with the question of what is macroevolution? Now, the correct definition, the real definition of macroevolution in evolutionary biology is evolution above the species level. So things like speciation and larger changes, as opposed to microevolution, which is changes within a species or population. This is the textbook definition from Zimmer and Emlin's second edition of their excellent evolutionary biology textbook, Evolution Making Sense of Life. Macroevolution is evolution occurring above the species level, including the origination, diversification, and extinction of species over long periods of evolutionary time. Now, that's different from what we're going to be talking about tonight, because we're going to be talking about the made-up creationist definition of macroevolution tonight, which is evolution between kinds. Now, obviously, in order to address the question of evolution between kinds, we need to be able to define a kind, which is generally taken to approximate a taxonomic family, but that's not always the case, and it gets really squishy, especially when you start talking about microbes or insects or basically non-terrestrial vertebrates, basically. Kent is going to say something silly like, has a pine tree ever given birth to a bear? Something ridiculous like that. Now, I shouldn't need to point out why that's nonsense, but that's nonsense because that's just some cartoon made-up version of what evolution is. Nothing that's alive right now is descended from anything else that's alive right now. If you go far enough into the past, we share a common ancestor with pine trees, but it didn't look like a human and it didn't look like a pine tree. So Kent is going to throw a bunch of smoke up about these kind of ridiculous hypotheticals that bear no resemblance to what evolutionary biology actually is about. So here's the creation model. Generally, we're talking about accepting common ancestry within families, and this tree shows a bunch of mammalian groups. These technically aren't families, most of these, but the idea is you accept common ancestry within groups, but then you draw a line, and you say, above that, there's no common ancestry. And you need a good reason to do that, and Kent's reason is the Bible, not any evidence. These lines are completely arbitrary. You could draw the line further back. You could draw the line there. You could draw the line wherever you want because there's no distinction to be made in terms of the actual biology of the organisms that makes sense to draw the line at family or order or class or any other taxonomic rank. If you're going to say this group shares common ancestry, but these broader groups don't, you need a reason. You need to be able to say what changes specifically are unable to evolve. So let's try to answer that question. We want to know what would count as macroevolution. The creationist definition is squishy. It's hard to draw a dividing line in practice. You'll say things like evolution between kinds or the evolution of a new kind of organism or I forget which organization it is, but CMI has like a definition that's like 5 words. It's like evolution of a new something. You can't use it in any objective way. But let's go through some hypotheticals and see if we can find what would or would not count as macroevolution to Kent and other creationists. Now, before we do this, I want you to keep in mind this saying. Microevolution is evolution creationists can't deny. Macroevolution is evolution creationists must deny. So will Kent accept any of the examples I present as macroevolution? Of course he won't. But what I want you, the audience, to do is consider each of these examples. And Kent loves this little trick where he says, what would a 5-year-old think? So as we go through these examples, I want you to think, if a 5-year-old looked at the 2 things I'm presenting that we can watch change, and would a 5-year-old say, is that a different kind of organism? So think to yourself as we go through these. Kent's going to say no. We know that ahead of time. But I want you to think what you would say. So the first question is, what if we get a completely new morphological feature? We get, a new limb, a new kind of covering on the organism, something like that. Well, it's still a whatever, so that's not macroevolution. But we can watch feathers evolve from scales, and the transition isn't even that hard. It involves changes to regulatory genes. You don't even have to get new genes for that. You just change the pattern of expression, and you go from flat scale to a conical feather to the familiar feathers that we see on birds today. The cool thing is this is not hypothetical. We can actually do this in the lab. And not only can we take the scales on chicken legs, and by changing their gene expression pattern during development, turn them into tubular feathers, we can do the same thing on alligators. And we can turn their scales into simple feathers. So this is not some hypothetical thing that maybe this is how reptiles changed. We can watch this change happen. What if we saw a new biochemical function, some new metabolic pathway or a new gene or something? Well, it's still the same organism. Maybe it got a new function, some new information, but it didn't change fundamentally what that organism is. Okay, fine. Here's an example from HIV-1 group M, a protein called VPU. This is one of the things that allowed SIV, simian immunodeficiency virus, to evolve into HIV, human immunodeficiency virus. Now, this protein has 2 functions in HIV. First function is to degrade a protein in our cells called CD4. It keeps doing that. It doesn't matter what CD4 is for this discussion, but it keeps doing that. But the new function is to antagonize part of our immune system called tetherin. So here we have its old function. This is the ancestral function that the SIV VPUs do. And here we have the new function. It antagonizes this part of our immune system. This requires at least 4 distinct amino acid changes in order to be able to do this. And you need all 4 of them in order to have that activity. So for any creationists watching, by the way, that's an example of an irreducibly complex trait. And we watch this evolve in real time because HIV didn't exist until about 1930. Now, of course, that doesn't count. So let's go up a level. Completely new genes? I would think now we're approaching something that some creationists, at least, would say, okay, that might count as macroevolution. Well, new genes, not hard to find. Sometimes you hear the phrase orphan genes, but the newer word for those genes is de novo genes, and we know exactly how those came about now. We know this because random sequences are an abundant source of biochemical function, whether they're RNAs or peptides. We also know that these random sequences in organisms are well tolerated. Surprisingly, they tend not to cause problems. So what we expect, if we're looking for an origin of genes that are limited to a specific lineage, we expect to find non-coding sequences that are similar in related lineages. And that's exactly what we find. We've now found these types of sequences in rice, in yeast, in apes. Turns out, now that we know how to look for de novo genes, we find them all over the place, and we now know their evolutionary history. So this is not a hard question to answer. There are completely new genes derived from previously non-protein coding sequences within genomes. Still not good enough, because it's the same thing, though. It hasn't become a new kind. Well, what about an amoeba becoming a new type of green algae? I think that should count as one thing becoming a new kind of organism. Well, this is happening right now in a genus called Pollinella. We're watching it happen in real time. This is an amoeboid rhizarian. Here is the kind of host cell right here. And these things eat things like green algae and cyanobacteria. Well, two species within this genus have acquired a photosynthetic organelle called a chromatophore. Not only are they eating the cyanobacteria and then using the bacterial cells for photosynthesis, those chromatophores are actually part of this larger cell. It's not just their food that they're utilizing, because we have evidence of horizontal gene transfer between the two, where the nucleus of the photosynthetic rhizarian is actually expressing cyanobacteria genes. The great thing about this is that this is a different kind of cyanobacteria from every other type of like plant chloroplast that we know of. It's a new instance of endosymbiosis. I'm already almost at my time, so I'm going to have to cut this down, but that's okay. Here's another one for you. What about photosynthetic animals? I would think an animal becoming a walking plant is going to count as a new kind. And we see this happening all the time. This is a process called secondary endosymbiosis, where animals are eating green algae and they're stealing the photosynthetic components of that algae and using it for themselves. This isn't a one-time thing. There are dozens of examples of this, from sponges to cnidarians like Hydra to mollusks. In some of these species, it's even the case that the same thing is occurring that I just described, that the genes from the algae that allow for photosynthesis are actually migrating into the animal genome. And in other species, including a vertebrate, this is actually a photosynthetic salamander, the photosynthetic organelles are transmitted vertically from parent to offspring. So here are the salamander eggs developing. You can see they're already green. In some of these examples, they have to eat the algae as larvae, but not so for the vertebrate example. They're actually part of the germline transmission of that species. So we have an animal becoming a walking plant. How does that sound for macroevolution? Thank you. Oh, and then I have lizards giving birth. So you have reptiles mostly lay amniotic eggs, but some have evolved live birth, including populations doing so right now. And one of these, actually several of these populations, actually have a new type of placenta. And I would think going from laying eggs to using a placenta to give live birth would count as macroevolution. I'm going to have to skip multicellularity. I'm going to have to do this faster. Okay, so Kent's model. Let's talk about Kent's model. I'm just going to go and see how long this goes and see what I have to do. So,
okay, well, that's time.
Yep,
Yeah.
that's time. So let's now look at Kent's model. In science, throwing stones isn't good enough. You need a better explanation to replace the previous consensus. Does Kent's model do a better job explaining extant biodiversity? No, it's not even close. In fact, Kent can't even explain Kent's model in a consistent way. As we're going to see, he's just blowing hot air. There's no consistency. It's all ad hoc rationalizations. And we're going to examine that more as we dig into that model later tonight. So to summarize, creationists claim macroevolution cannot occur. There are lots of creationist definitions for macroevolution, but none of them are actually the correct biological definition. But at the end of the day, the specific definition doesn't matter. By any reasonable standard, macroevolution has been observed, and you just have to close your eyes and pretend it's not happening, stick your head in the sand, to deny what we can plainly see in front of our eyes, that macroevolution happens. There you go. Okay, 1 minute over, plus I skipped some stuff, so probably about 2 to 3 minutes over. I can cut down at the front end. This is where I'll cut down. All right, I'm going to cut down on that front end because I want to make sure I get through those examples. What was that?
People watching will know that the idea behind special creation is that there are specially created separate ancestries.
Yeah. So I don't need to. Yeah.
All right.
I like it. the HIV thing. I'm not sure I've ever heard Kent talk about HIV, and I like that, and I want you to bring that up because why
Okay.
did a fake virus
Corpse here, come on in.
transfer to humans?
What up, boys?
Hey,
All right, Lane, what were you saying?
why? Like one of those things is like, how do creationists deal with the fact that a virus from apes transferred over to humans?
I mean,
Oh,
they'll
no.
say it's not really a new thing, that speciation isn't macroevolution, it's just changing a host,
Yeah.
it's still the same basic virus.
Yes.
So I do predict, though, that Kent Hovind will simply dismiss it as being a virus, and he will not engage with the whole protein gaining a new function.
Oh,
And he will
I should.
I'm gonna predict a specific response too. He's gonna ask you if the virus grew limbs or not, and that's gonna be his threshold.
Yeah, I think that actually might be true.
Good to know.
The curious factor for me is that it's HIV, and the demographic Kent is in generally has some conspiracies around HIV.
Yeah, that too. Okay, so that actually reminds me, though, I will add the paper about the plasmids gaining extracellular transmission.
Yeah, that's good.
So the
'cause
supplemental thing. So if it
turning
goes well.
into
Exactly.
virus, yeah.
And that's a thing that we're watching happen in real time, so I'll have that in the back pocket.
Well, it's still a virus, and you can say, well, it wasn't a virus when we started watching.
Wasn't a virus when we brought it into the lab, and then it turned
Right.
into one. So
Exactly.
Yeah.
Yeah. So I know you also
I'll
wanted to
definitely
get
put that on the
into,
list.
if it comes up, I know you also wanted to get into things like how fast do we actually need creationist speciation to happen? Because a lot of times people say, oh, we have 4,400 years, right? But we don't. We don't even have close to that time.
You don't even have 1,000.
In many cases, yeah.
You have to have modern. You have to have most modern species by the end of the so-called post-flood ice age.
Yeah.
Which is
So
what,
actually,
500 years, 600 years if you stretch it.
I argue you have to have all, like everything you see in Ice Age Europe being diverged.
well, so
by the
here,
time of that Ice Age.
here's one of the areas I would like to see gone into. So because Egypt appears in Genesis as a fully fledged civilization that Abraham can go to, because you have to remember, Abraham and Sarah go through Egypt in the Bible, in Genesis. That's the first time we hear about Genesis. That means that the Egyptian civilization had to already be established before that. Right? Now, if you could screen share for me, Dan.
Yes, absolutely. Let me, here we go.
Okay, so this is the Narmer tablet, and it's famous for being the first instance of definitive use of hieroglyphics. It has a few cases. I don't know. Can you see my mouse? Yeah, you can kind of see my mouse. So
Isn't it those things that they say are dinosaurs, even though
they
they're
are.
lions?
They already say that about that. We might or might not get into it. I have a reason as to why maybe saying that's a few reasons as to saying why that's a dinosaur is probably not a good idea. But so this is important because we're not entirely sure what this means. This might not be a hieroglyphic. This is the hieroglyphic for city that persisted all the way into the New Kingdom. And right here we have the name of the king here, Narmer. Right? So this is the earliest that we can say Egyptian history is beginning because they're starting to write things down. Earlier than this, Egyptian artifacts are prehistoric. So this has to be before Abraham, right? Even if you disagree with the scholarly consensus in Egyptology about what the dates are for these, we now know that we have stereotypical Egyptian depictions of several animals, at least buffalo and falcons. But now you might say these are fantastical lions. But here's the thing: there's a couple of reasons for this. One, the long-necked lion is a stylistic motif that gets used in Egypt. It's just there for decoration, right? But the other thing is, in this particular case, this object is actually used to mix cosmetics, and such objects always had a central depression. So the idea is you get to hold the thing in your hand, so you have a nice big thing to grip, right? But you don't want to have to use that whole surface for mixing up some small amount of, like rouge or something, or some eyeliner, right? So that central depression between the necks is actually where you put you take your stick of whatever pigment you're going to use, you rub it into that, you pour some water in there, you stir that around, and then you can apply it to your face. So these aren't just long neck lions for no reason. They're there for a practical purpose. So we already have evidence that at least falcons, bulls, and lions have diverged by the Old Kingdom. But the depiction of Egypt in the Bible is almost always, and universally, even by Christian scholars, brought into about the Middle Kingdom. And here's another, by the way, Old Kingdom depiction of a definite lion. This is not fantastical. This is just straight up a male lion. So even
shoot me that link if you don't mind.
Oh, I will shoot all of these to you.
Thank you.
So this right here, this is from the Metropolitan Museum, right? This is a public domain image even. This is a male lion. It's not fantastical in any way. It's slightly stylized and it's a bit blocky, but I mean, that's clearly not fantastic. It doesn't have a long neck or anything. So we can also say for certain that Panthera has divided into at least lions and tigers and probably leopards and jaguars and such, right? But we also, in the Old Kingdom, have this tomb, right? And in this tomb, we can see waterfowl, we can see jackals, which means that Canis, the genus Canis, has already diverged into at least Canis aureus and Canis lupus, and presumably Canis latrans, which, by the way, if you bring up Canis latrans, inform Kent that there's no such thing as Canis coyotes. It's Canis latrans, and he should fix himself.
Honestly, I don't trust myself on stuff like that. I would just say, like, foxes, coyotes, and wolves.
Fair enough. But we also have, in here, we have vultures, we have eagles, we have owls, all evident in here. We have differentiation between, actually, I'm not sure I can say we have differentiation between ducks and swans in this particular image. But, so just the animals identifiable here include kind of generalized galliforms, but we also have buzzards, owls, eagles, jackals. And then, since the biblical depiction of Egypt is usually centered in the Middle Kingdom, oh, also this thing right here, we have at least 2 separate species of antelope and what's probably a species of goat here. And we also have a goose down here. So this is in the same tomb. So we probably have ducks and geese just based on this one tomb, right? And this is from the Old Kingdom. But then we can take a little trip over to Gardner's Middle Egyptian sign list, right?
Hang on, before we go any further, Dapper, I just want to make sure I'm following the point here. The idea is that you get off the Ark, we're putting that at approximately 4,400 years ago. Now, this Egyptian history is like, Middle Kingdom is like right there.
Right.
So we're talking decades to centuries now. And you have to squeeze an ice age in there too. But by the time these depictions are made, and I don't know if Kent agrees on the timeline here, but I mean, you could fast forward 1,000 years.
He has
and
to
you still end up with not enough
Abraham.
time to diversify all this stuff.
Right. We have to put this at least before Abraham. So by Abraham, all this diversification has occurred. And it's essentially the same amount of diversification that we see in modern Africa, right? So we've got bulls, we've got, let me be able to scroll. We've got horses, we've got goats, we've got rams, which are not going to be the same.
That list is fantastic.
Sheep. We've got cats, dogs, we've got jackals, we've got lions, we've got the hippopotamus, the elephant, the giraffe, an oryx, a specific species of antelope, the oryx, the ibex as a different species of sheep.
Nice.
Than before. We've got a baboon, we've got a monkey, a hare, we've got it's the same baboon, but you get it. So you scroll down, right? And that's just the mammals. If we get into birds, right? So if I just search for, say, falcon, right? So here's the falcon list. We've got the Egyptian vulture, we've got the buzzard, not the same species. We've got the falcon. Let's see. We've got a different vulture. So we've got 3 species of carrion feeding birds of prey already depicted in ancient Egyptian hieroglyphics before Abraham.
That's great.
We've got owls. We've got guinea fowl. We've got the hoopoe. We've got the lapwing. We've got the northern bald ibis. We've got the sacred ibis.
Specific.
We've got the sacred ibis, which is a separate species. We've got the flamingo. We've got the glossy ibis. We're already at 3 species of ibis. We've got the saddle-billed stork.
And we have 1,000 years to do this if we're being extremely generous and ignoring well-accepted Egyptian chronology.
Exactly. We've got the heron, the cattle egret, the ostrich, the cormorant, the swallow, the sparrow, the white-fronted goose, the pintail, the widgeon, 2 quail chicks. We've got quails. We've got ducks. We've got plovers. We've got geese. I mean, what do you want? Literally.
So we know that they're one kind, and they rapidly radiated, and
which Gene said doesn't accept as far as I know.
You need to have an explanation for that. Now, creationists like to involve created heterozygosity, and that makes no sense because there's not enough allelic diversity. So what they say is, well, you get a bunch of genes that were actually lost in the arc common ancestor. They actually just had more genes, but then you have to wonder where are the pseudogenes, because we know what broken genes look like, and they didn't just poof out of existence in the genome. They're like, we know what that looks like, and we don't see that. So I'm going to take it in that direction with this kind of stuff, because Kent does not know the genetics, like, at all. So like when we talk about like the creation model, and say like, no, you need to explain this. Tell me how the genetics works, and we're gonna have fun with that.
This is basically just evidence that like you basically got like the entire avian fauna of modern Northeast Africa, just in straight up hieroglyphics. This is how these people were writing. Now, granted, it was mostly the priests that were writing this way, but even the various.
Whoops! I still want that to be yours. Where'd your screen go? Sorry.
Oh,
there you are.
Yeah.
There you are.
We know that by the time of Abraham, at the very latest, all this is already established as part of Egyptian civilization in their writing system. I mean, do you remember there were like 4 different kinds of ibis represented?
What website is that?
That's just Wikipedia's version of Gardner's Middle Egyptian sign list, which is the standard Egyptological way of keeping track of hieroglyphics.
Fantastic.
Yeah. So they have sections like G is the bird section, and I think like B is like the body part section or something.
All right. If this is brought up to Kent, I am going to say what Ken is going to say.
Bring it.
That doesn't matter.
No, I mean, it'll be an automatic dismissal no matter what evidence you bring up.
It's going to be a hand wave. That's what's going to be.
Okay, so that doesn't matter. Okay, Kent, you're saying that it doesn't matter that within a few centuries, being generous within a few centuries after the flood, we have all this diversification. You're saying that doesn't matter. How many kinds were on the ark? How do you define those kinds? And if it's at the family level, then how does this speciation happen? Explain to me the genetics of how this actually works. And if it's not at the family level, if he's going to say, well, it's more specific than that, now you start to run into a big problem, because you don't have to fit thousands of kinds on the ark. You have to fit tens of thousands. It's not like a little bit more. It's like an order of magnitude more.
Yeah, and so one thing I point out is like, even if we just go to just cats, right?
Right.
According to this, just these Egyptian hieroglyphics, right? We know that Panthera and Felis had diversified. But we also know that division is much closer than the division between, say, a lot of these ancient forms of cats, and even things that are only loosely associated with cats, like the saber-toothed cats aren't technically in Felidae, or the saber-toothed cats, which are in Nimrabidae, and I don't even bother bringing up that they're not in the same family.
We're just gonna make them cats.
So you need to fit in about 150 to 200 species of cats.
Yes.
Into about the time frame between Noah and Abraham. Yeah. So we're looking at like you might actually be getting into like below 3 or 4 in terms of generation time.
Yeah, it's actually within. I'm actually going to put that in the slides. Noah to Abraham range.
Yeah.
Yeah, because that's where you have the right. So if you go Noah to Abraham, you need to get all those cats.
Right, because he's going to dispute the chronology.
Right, well, you just use the biblical chronology.
Yeah, just go straight up, go right to the Bible. Say, hey, Abraham's in Egypt. The depiction of Egypt in the Bible is pretty solidly Middle Kingdom. So even if we condense all this chronology of the Old Kingdom to between
into the Middle Kingdom,
right, between
you got like two, maybe 300 years. Yeah.
Yeah.
Nice.
So we'll condense it all between Babel and Abraham, because until Babel, apparently we don't have different civilizations.
Okay. So we got that one nailed.
That's how long it takes to get from the Old Kingdom to the Middle Kingdom is Babel to Abraham, which is going to be like, what, a couple centuries?
Yeah. All right, so I'm going to switch screens here because I feel like we've tackled hyper. So these are the other topics that I think might come up and be relevant. So the hyperevolution thing, I think we nailed that one. We know he's gonna be like, well, radiometric dating, whatever. The thing that creationists always go to there is, of course, the RATE project. And I know, Corp, I know you love to rag on them for their misusing a calibration study to claim that, what was it? There's carbon-14 in diamonds?
Yeah.
Yeah.
Yeah. So the one there is that they say, "Oh, look at this! They found carbon-14 in diamonds. Therefore, the diamonds are young." They were using
It's not just like people like me and us who are shitting on that now. The guys who wrote that original study, Taylor and Southton, put a peer-reviewed rebuttal to it in the journal Radiocarbon. And I only ever saw one tiny response to it by Brian Thomas, and he hid it in one of the creationist journals. And it's like, dude, just submit it to Radiocarbon if you think.
Do you have a link for that?
The one from Taylor and
the response to rate.
Yeah, I can get it for you.
If you have that one, hit me with that one, because then I'll just plop that up there and that'll be that. And then the other one.
You got it.
What?
You got it.
And then the other one, of course, is Oklo, which is like one of my favorite things that I've ever learned about because it's amazing. So let me try to explain Oklo, because I don't think I've ever actually explained this out loud. I've explained it in text. But let me see if I got this right. So you've got this formation. It's Nigeria, right? Was it Nigeria?
It's in Africa. I don't know exactly.
I'll look.
I'll find it out right now.
Somewhere in there.
Right.
So you've got this formation, Oklo, and it's uranium ore, and they used, I forget what type of dating to date the rocks surrounding the uranium formations to between 1.8 and 2 billion years ago. Now, based on that and the rate of uranium decay, you can make predictions about what you expect to find in the uranium-containing formations. Okay, they're 1.9 billion years old, it decays at this rate, we should see whatever frequency of daughter isotopes. They saw less than they expected, which is weird. So they hypothesized, well, what if there was fission happening here? What if there was fission happening? And if there was fission happening...
I found the country.
What was the country?
Gabon. Or Gabon.
Oh, it was Gabon. Thank you.
Gabon, depending on how French you want to be.
Thank you. So now they say, okay, if the fission happened 1.8 billion years ago, we should see fissile products, A, B, C, D, E, in these amounts based on how much uranium and its daughter isotopes are missing, right? So they can make a prediction based on if the fission happened back then, what do we expect to see now? And those were spot on, right? So now we know that we can conclude that there was fission happening back then, and because the predictions based on the ages of those rocks were accurate, we know when the fission happened, right? So we say those rocks are 1.8 billion years old. If fission happened then, we can predict what should be there now. We made those predictions and they were right, so that verifies the 1.8 billion year age. Now that allows us to verify that the rate of both nuclear decay and the processes associated with fission all happened at least going back to the age of the Oklo reactors in a uniform way all the way to the present, because those occurrences allow you to confirm that the fine structure constant was the same, and that affects the rate of neutron capture. Neutron capture affects not only the rate of fission, but also the rate of decay. So, because there's neutrons being released when that happens, so if the fine structure constant is different back then compared to now, or it's changed over time since then, we're going to see different ratios of daughter isotopes, both from the fission and the decay. The fact that we can make accurate predictions about those daughter isotopes means that the fine structure content, and therefore both fission and decay, have been constant for at least 2 billion years. How'd I do?
So I think that was pretty excellent, although I'm not sure. Is it important to bring up dating for macroevolution?
I think what he's going to say is he's going to say, well, you can't trust the Egyptian chronology. We don't know the timing. Radiocarbon dating's no good, yada, yada, yada.
See, I think, so I like that idea where we say, hey, look, there's actually really good reason to think that radiocarbon dating and whatnot is accurate. But I also think it might be even more effective just stick with, it doesn't matter if the secular chronology is accurate. You have to fit this in before Abraham.
Yeah.
You do. I don't have to. I don't care about Abraham and when he was, where he was when. You have to have this before Abraham. So if you want to toss out the Bible, by all means, but then why are you here?
I'm going to use that. Now, I do really, again, I like getting into the technical waters with Kent. I like the idea of that because he cannot.
Oh,
he just can't. So, like, if we start going down that road of, like, no, we're going to talk about how we know radiometric dating is valid, and I have other topics on here, you know, we're going to talk about Like if he's going to say, well, we don't, the times don't matter. We know that humanity only goes back 6,000 years. Like, no, we're going to have the genetics conversation then. And you're going to explain to me why you think that's the case. And you're going to justify it. And I'm going to show you how it's wrong.
So this is a bit tangential, but does Jeanson say that Y chromosome Adam goes back 6,000 years ago, or is he smart enough to go to 44,000 or 4,400?
He has to squeeze Y chromosome Adam into a shorter time frame than mitochondrial Eve.
Yeah. Does he bother to do that?
I do not know. He did not get into it in detail. Oh, okay. Dakota's here. Thank you. I did not notice. Sorry about that, Dakota. Add you in here. Welcome.
Y chromosome diversity isn't like hugely less than X chromosome diversity, is it?
It's so the diversity is less, but the rate is slower.
So there's not a huge mismatch in terms of our predicted timeline from the standard model.
It's so for mitochondrial most recent common ancestor, depending on your population size estimates, it's 60 to 200,000 years. And for Y chromosome most recent, it's 200 to 300,000 years.
Oh, so actually Y is much bigger.
They just barely overlap potentially.
But Y would be significantly farther back if you take like the average.
Yeah.
So we would
and that actually reminded me of another thing. Thank you.
So we should expect, now granted, there's that chance that the actual overlap is in, or the actual dates for each are in that overlap. What you would predict based on the creation model is that you would recover much more recent Y chromosome.
You have to, yeah.
Because it's got to be Noah, unless we're going to say that like he's somehow magically passed on someone else's Y chromosome.
It wouldn't matter. It would still converge at him.
Well, no, because, okay, how about this? Maybe Noah is the first guy who's into the whole cuckoldry thing.
Oh my god.
But it wouldn't matter though, because he could still only have one.
But they're not really his kids, they're just his wife's kids.
Oh, they're not his kids. Okay, I see what you're saying.
It's his unnamed wife's boyfriend's kids.
Yeah.
I would think that would violate the whole like you're not a deviant, therefore I'm going to save you.
Yeah.
No. It's because of how much worse everyone else was in comparison.
Yeah, guys. Everybody else was eating pineapple and pizza.
Okay, we're getting into dangerous territory.
On that.
Okay, let's thank you. Let's bring this back. Okay.
I sent you the paper on
Oh no,
Thank you.
I'm fine with pineapple and pizza. I don't have strong problems with it. It's not.
That is violating terms of service right there. Pineapple.
If you bring up rate,
errors all over the place. I'll fix these. Don't worry.
If you bring up rate,
rate. Sorry.
Yeah, if you bring up rate, you have to answer the heat. You have to bring up the heat problem to it.
Oh, absolutely. If you fit that much radiometric decay into,
now, I don't think he really understands the heat issue. And keep in mind, you can't. It's a mixed bag, because if you throw the catastrophic plate tectonics heat problem too, he'll just deny plate tectonics because he thinks that's a lie.
That's true. He unlike AIG and almost everyone else, he denies that the continents have actually really moved.
He thinks that they are connected by dirt on the ocean floor, and that there isn't, like a big ass spreading ridge going across the planet like a baseball.
I think he does actually accept that there's currently a spreading ridge. I think his point is that if you were to drain significant amounts of water, you would be able to walk to basically any landmass you want, which is broadly true.
While crossing a giant mountainous ridge that you need to put a bridge across?
No, because you don't need to drain that much. You just need to drain enough to get like the Indonesian islands and Australia, or not even Australia. You just need to get there to be enough so that there's a fair bit of land between like the Indonesian islands and North and South America, which actually any given glacial maximum will do for you. So he's actually not super wrong about that. Any glacial maximum will get you those land bridges.
Well, no, when Kent makes that argument, he's not talking about land bridges. He's talking about literally if you drained all the water off the planet, the continents are connected. I've heard him make that.
He says that too, but he usually doesn't ever go into some argument about a complete land drain is the reason that animals can get any place, and he usually just says...
Oh, no, that's not what I was going at. I was going at the fact that he literally denies continental drift.
Oh, he does, but when he says that specific thing, it's literally just a joke he tells.
Oh my god.
I'm not kidding. It is in fact a joke.
Thank you for reminding me. I have to make sure I mention at the beginning, at the top over here, when I'm like, Kent doesn't have anything to say, I have to remember that I have to say he's going to say something about SpongeBob.
Absolutely, you need
Oh,
a
yeah.
SpongeBob slide.
Right here,
like,
I have
on
to
the
say that he's
on,
going to
like-
say something about
like
SpongeBob.
Platonics. Yeah, like with Kent, if he says Platonics is fake, all you have to say is we can literally measure the continents moving right now.
Yeah, I mean that's the whole
Why are
point
they
of this
moving?
thing, right? We can measure all these things that I'm talking
So,
about. It's not
I
theoretical.
actually recommend a couple things. One is have a slide with the picture of SpongeBob doing the imagination rainbow, right? And literally title it, "Is this imagination?" And give a few bullet points as to why. No, these are all points of data that we have confirmed.
Thank you. Will
Straight up
do.
evidence. And here's my other recommendation. Make sure that instead of just straight up your webcam, you're using the OBS virtual webcam, so that even if you're not being screen shared at the moment, it doesn't matter. You can bring up the slide anyway by just switching to a different camera view.
Nice.
Using the slide. So that way, even if, like, I don't know who's moderating, I assume it's going to be standing.
It's standing.
Yeah. So even if he's not on the ball or he doesn't want to screen share you, doesn't matter. Unless he's going to completely remove you from the Hangout, it's on screen.
Nice.
Yeah, that's smart.
Because, I mean, look what I can do with the OBS virtual cam. I can go like this, and now you can see my Blender file.
Are you using Windows or Mac?
I'm using Windows.
Yeah, it doesn't work on. I don't think you could do it on a Mac. I gotta find something else that allows me to do that.
Yeah, or just stop using Mac like I'm crazy person.
I love my
Or you
Mac.
could have a computer that doesn't die with every update, like we have to suffer through.
All right. Well,
Fair
here's the thing about Mac. If you do the computing power to dollar ratio, like, it's really bad.
I built a Hackintosh,
Oh, okay.
so it doesn't matter.
I mean, hey, fair enough.
Of course, then updating it's a pain. But anyway, now we're off topic. Let's get back on topic.
I just put in a message I got on Reddit from Call Me Evil. That's also for Dan, by the way. So yeah.
Oh, okay.
Oh, and Dan, I did send you all those links that I pulled up.
Thank you. Appreciate it.
Yep.
Okay, great. Okay, so other stuff that I expect to come up. Who knows about Neanderthals? I have no idea. Maybe. E and F kind of go together. You know, what are kinds? Like, give me an answer. What, and it goes with the question of what cannot turn into something else, right? What are the boundaries of evolution?
I would ask a specific, like, is a false saber-toothed cat or is a single animal turning into having descendants? Some of whom are false saber-toothed cats, and some of whom are tigers. Is that a change? And if not, okay, what about a single common ancestor where some of them turn into civets and some of them turn into tigers? No? Okay. What about a common ancestor where some of them turn into aardwolves and some of them turn into tigers? Because aardwolves they're actually hyenas, right? They might be called earth dog or earth wolves in Afrikaans, but they're freaking hyenas. And if that's not a change in kinds, okay, well, what about something turning into a bear and turning into a cat? No? Okay, what about something turning into a pangolin and a cat? What about something turning into a horse and a cat? Just keep going back.
Yep.
And when he says, no, I don't think so, then you have to say, why? I need specific reasons why that is impossible. Because you gotta remember, like, the fossil differences, right, between say the earliest say false saber-toothed cats that we have and the earliest so we'll just go with the actual saber-toothed cats and the earliest.
What is that? That was E and F, right? We'll go with E. Actually, we'll say E.
Because one of the things to remember is, like, what's the difference in terms of fossils between the saber-toothed cats and actual Felidae?
Nobody,
It's
the only people who knows
the
are the
inner ear.
nerds.
It's details of the inner ear structure. Literally. That's the diagnostic difference between those two groups of animals. It's inner ear bones. You could look, if you cut off if you just bore a hole through their ears and maybe pulled out, like, the teeth, no one would know which group these animals belong to.
Nice.
You cannot tell. Their postcranial morphology is identical. The only difference is true saber-toothed cats tend to have short tails, but guess what? Ever heard of a lynx or a bobcat? Short
Dapper,
tail.
we're gonna have to talk off the air because we don't have a whole lot of time. But I do want to go through that list of things you just said and, like, have that ready because that's a really nice way to go. Okay, can A and B, do they share a common ancestor? Can can something evolve into both of them? Okay, fine.
Absolutely.
Yes, a leopard and a lion, whatever, right? And then
Start really small. Yeah.
Yeah, I like that. That's a neat trick to have up my sleeve. So thank you for that.
Yeah, that's one of my favorite things to go with. Is just keep going one step back from where the creationist says, "Oh yeah, that's common."
And that's the arbitrary nature of this. Like,
there's
why
any
here,
line
why not there?
any line you cut is going to be arbitrary. I don't care how far back you go; it's arbitrary because the same criteria that you use to establish common sense above that line works just as well behind that line.
Yeah. I think it's Erica has the thing that I've heard her use a couple times, Guts at Gibbon, where it's okay, you accept paternity test, right? So you could figure out if two people are siblings. And then you could use the same basic principle of genetic testing to figure out grandparents, great-grandparents, on and on and on. Why does that stop working at some point in the past?
Right, because the same techniques ultimately could recover humans as related to Pan. So Homo is related to Pan. Homo and Pan together are related to gorilla. Homo, Pan, and gorilla together are related to Pongo. Homo, Pan, Pongo, the whole hominid group is related to Hylobatids, the lesser apes, the gibbons, whatnot. Hi, Erica, if you watch this. The hominoidians are related to the rest of simian.
So I'm going to put that away because that's been up for long enough. And Covert Cuttlefish is here. You want to join us? Come on in.
Hello, everybody.
So
come in for a little bit.
I'm sure we got about 10 minutes left. I'm sure you've watched debates with Kent. So what are you feeling?
What words of wisdom?
Just make sure he doesn't lead you off topic, man. Like we saw it during Lispers, right? Like Lisper did his 10 minutes. It was awesome. Hovind went on a tangent to geology for some reason in an evolution debate. Who knows why?
Right. So
and then Lisper followed him along.
Yeah, it was. So actually, I would recommend doing what I did in my debate, which is write down everything he actually says while you're muted, right?
Yeah, that's exactly what I do.
List off all the things that are just irrelevant and say, you said this, this, and this. It's irrelevant. I'm not going to discuss it. Because that's what I did, and it helped me stay on topic.
Yeah.
Because you just because one of the things he likes to do is go into some stupid fictional biography of Charles Darwin.
Mm-hmm.
I don't know why. It is apropos of absolutely nothing. It's never important. Because as far as I'm concerned, like, you don't like Charles Darwin? Great. I don't care. He's not actually important to modern science. He's historically significant and nothing else.
Just ask about Wallace if he brings up Darwin. They co-wrote that first paper.
Okay. But yeah, so like list all those things in your first rebuttal real quickly, like rapid fire. Like Ken brought up a fictional biography of Darwin. He brought up some detail of, his canopy theory. He talked about pine trees.
Added this, and I will fill this in as we go.
Yes.
I want to see how many there are at the end of it.
Oh, that'll be fun too. Yeah.
It's going to be size 8 font by the end of it.
But seriously, just list them off rapid fire as fast as you can speak them and say, they're all irrelevant. I'm not touching on any of them. They don't matter. Because if he wants to waste his opening statement, good for him. He can waste as much of his opening statement as he wants. Because that's what he did with me. He went into ridiculous things like I said, the big one that stands out is his fictionalized Darwin biography. And it's like, okay, sure, take your 10 minutes up talking about Darwin, because I'm never going to talk about him.
Yeah, all his openings have been very similar that I've watched, and I'm wondering if he's going to call me. I don't know if he's going to call me a propagandist or brainwashed. Is the question I really have.
It does seem to be one of the few actual variants.
Stan's professor, so it's obviously going to be a propagandist.
Yeah, make sure you try to lead him down the path of saying that you're actually just lying, like you're making all this up. None of this is real.
Yeah. So
as part of the deep state evolutionist or something.
When it comes to someone like me, who okay, I've got a history degree. I don't have a degree in biology. I don't have a degree in geology. My one degree is not actually in the relevant fields. I'm just trying not to brag, but I would call myself extremely well-read for someone who doesn't have a degree in any of these fields, which I think is fair.
I agree.
Okay. So he would probably call someone like me brainwashed. In fact, he did call me brainwashed. Not in that word, but it was the clear implication. Because he's like, oh, those professors, they lied to you. And I'm thinking, like, what professors? I took one biology for non-science majors class as biology, and then I took an astronomy class to fill my other science credit, right? Like, I don't know what you think, which professors you're talking about, but anyway. But I think with you, where you're actually an active professor teaching biology in a school that isn't moronic, the school I'm talking about, the school isn't run by morons, so they actually teach real biology, you're a propagandist.
I'm not gonna badmouth my employer on the air, but
How about this? They're not moronic enough to teach creationism at the least.
right,
Fair.
correct.
Yeah. So you're so I think you would be a propagandist because
I think you're probably right, but I hope he calls me brainwashed.
be prepared for both. Have something in the back of your mind, but
Brainwashed propagandist.
Brainwashed.
well, I mean that could be it
Double.
too. Well, he could actually go that way because he could be like, you got deluded by all your professors, and now you're teaching the same thing.
Yeah.
So, because I mean, you can be both, right? Like,
Could
if
happen.
you're the best person to write propaganda is the person who's already brainwashed, right?
Because you believe it.
Yeah. For you, it's not just propaganda. It's what you think is right and should be promulgated throughout. So, he might go for both. He also could go for neither because it's not usually central, and he usually starts bringing that stuff up later. Also, I would be prepared for when he starts doing the argumentum ad baculum in terms of the afterlife. Like, I don't know if you're
that would
comfortable.
just go on the tangent slide.
Well, the thing is, he'll bring it up at the end.
Yeah.
He tends to leave off with the argumentum ad baculum because when he realizes that none of his other arguments have any purchase, he then goes with like, "Oh, if you don't think I'm right, I'm going to beat you up for all eternity." Like, okay, Kent, great.
Sure. And we'll make this Y now. So what do we think? We got a few more minutes. Any other topics that we think could conceivably come up? And I realize that we may be giving Kent Hovind a little more credit here than necessary, but like what, trying to anticipate here, but I mean, anything else? Anything I should have in the supplementals ready to go?
Like, as Dapper said, he's probably going to go on about irrelevant stuff. But outside of science, he's probably going to go on irrelevant stuff like atheism or naturalism.
Yeah,
Be prepared for some sort of talk about naturalism or something.
I would honestly have a statement prepared about your metaphysical stand, even if it's my metaphysical stand is irrelevant.
Yeah.
Even if it's that. Just have something prepared to say, like...
Got it covered. Here we go.
Okay. Yeah.
I think off air though we need to look at what the calming email sent me, because this is kind of crazy how much diversity they accept in plants.
There we go.
Well, the thing is, okay, so here's the thing, right? No one cares about plants.
Oh, I know.
And
That's the thing, right? That's the
creationists
problem.
only care what the lay people care about. No one goes to botany channels on YouTube, and there's a reason, because people don't care.
Now you're gonna have the
Who
botany
cares
people
about
on
plants?
that.
Call me email.
Don't do that.
Look, I'm not saying botany isn't interesting. I actually find it really interesting, and I think there's a lot of awesome stuff going on in botany. But you ask the random Joe on the street how much he cares about botany, he might not even know what botany is. Honestly. People,
The
like
other problem?
average Joes, they don't care, so creationists don't care.
Well, the other problem is that they'll just do something, they'll just say, well, it's a different standard for them. Like last night? Yeah, it was last night with Jackson Wheat and Kevin Anderson. Jackson brought up insects and diversity among insects, and he was just like, well, like that's not a family, that's orders, or are the kinds for insects or whatever. Like he just like changed it on the fly.
He also used this weird excuse, like they don't have to be on the ark, so they can keep more diversity, I guess.
They definitely do need to be on the ark. There's a lot
Absolutely.
of insects that would definitely have died in a global flood.
Yeah,
would
literally
really
any
be on
insect.
the ark.
Anderson wouldn't accept basically any distinction of any level above species. He wouldn't be.
Well, that was the weird thing. He and Jungle Jargon did that, right? They were both like subgenus level in terms of where they were like,
Yeah,
I'm
subgenus.
absolutely okay at accepting these. So like I don't even know if Jungle Jargon, like he seemed to be like, I'm not sure that like jaguars and tigers are in the same kind. It's like, are you kidding me?
It's
Like,
kind of crazy.
How? So, but the thing is, he also said that, people have figured out the logistics of fitting all the animals into the ark. Yeah, by assuming a vastly smaller number of animals than your idea would require. That's how they did that. Because you have this balancing act, right? Where the farther back you put this kind line, the harder it is to say, oh, this is an evolution, right? Because if you go back to order and you're like, oh, rhinos and horses and tapirs and donkeys are all the same kind, then most people are like, then what's preventing the rest of this? But if you go too far forward and start saying, oh, genus is the kind, or even some subgenus level, then people are going to be like, okay, well, how are you possibly going to fit all of these? So you're telling me that you had, like, what, 40 proboscidean species on the Ark, along with dozens of sauropod species at least?
And don't forget the extinct ones.
Well, yeah. Well, that's why I said, even if you say some of
there are
them,
dozens of, yeah.
Yeah. So the problem with sauropods is that, or Mesozoic animals in general, is we don't have a clear way to tell how many species there would have been. We only have how many we have now. There presumably are more because we keep finding new species. So presumably we haven't found all of them just now. It's unlikely. I guess I can't say it's impossible, but it seems unlikely that we just now found every species in the fossil record.
Right. We just happen to be so privileged that we finally finished that project.
Right. And you would expect if that were to ever happen, that the rate of finds would start to taper off. But currently the rate of finds is accelerating.
Yeah.
So it's very unlikely that this is the point where we just hit the wall on paleontology and now we're done.
Yep.
So that's one of the things is if you ever have to go into like Mesozoic things that are going to have to be on the Ark, you have to say things like at least, because we don't know what else is out there that we would have to conclude. Yeah. And Kent will not give a taxonomic level. He will be very hesitant to say that anything other than extremely closely related things are definitely related.
Well, when it comes to kinds, doesn't Kent follow if they can make offspring, it counts, and if they can make fertile offspring,
he does, but he won't even if you give him examples, he won't agree to anything higher.
So here's the thing. He goes with if they can produce offspring, he doesn't go with fertile. So if they can hybridize at all, they are in the same kind. But if they aren't, it doesn't make them not in the same kind. Because if you bring up, say, like, hey, we don't have any evidence that, say, a bobcat and a lion could interbreed, and it doesn't seem likely. They'll say, well, they might have lost that ability. Or if we bring up, like, ring species where the two ends can't interbreed anymore, they'll say, well, that does, sure, they may have lost that ability over time. But originally they could interbreed. And then at that point, it's like, okay, well, breeding doesn't matter to your kind thing then. Because breeding can confirm a kind, but not breeding can't disconfirm. So we have no way to disconfirm a monobaramin set. He doesn't know the word monobaramin, I guarantee it.
So on that note, I think that's a good place to wrap this up. So Lane, hit it.
I went and confirmed it to make sure I'm not going to be completely wrong here. Which is that I wonder how many sauropods they had in the Ark. Was it like all sauropods are one kind?
The excuse they have there is that they're babies.
To the point where titanosaurs diplodocids.
Diplodocids? Yeah, there's the titanosaurs, the diplodocids. There are a host of families just in the sauropods. Yeah.
If they maintain their family, if the family barrier, you're gonna go insane because you're going to have dozens of sauropods on your Ark.
Yeah, but I do think we should probably wrap up. We can probably continue a little bit off air, but
I think so. So thank you all for contributing. I've taken notes during this. Thank you all for watching. And tomorrow, 8:30 p.m. on Standing for Truth, me versus Kent Hovind. It's gonna be fun. See you then, everybody.